Okay, we're going to take a look at inverse functions today. So once again, this is nothing new. This is something you covered last year. So hopefully this will come back to you pretty easily. So the inverse of a function, we use the symbol f raised to the -1. We say f inverse. Sometimes we write it like that. Sometimes we write it with an x like that. Okay? A function is not guaranteed to have an inverse. Okay, so it may or may not have one. If it does, it must pass the horizontal line test, or HLT for short. Okay, so it's just like the vertical line test, except now you're drawing a horizontal line. If it hits it in more than one spot, it would not have an inverse. Now, keep in mind the inverse graph itself must still be a function. And if it's a function, it must pass the vertical line test. So the original function, which we denote by f of x, and the inverse function, which like we mentioned, we denote as f raised to the -1 of x, it's read f inverse of x, they are reflections of one another over the line y equals x. So if you forgot what that is, y equals x, splits quadrants 1 and 3, okay, right down the middle. So this is y equals x. So if we have a point up here on f, if you were to reflect it over this line, it would end up being its mirror image on the other side of that line y equals x. Okay, so it's a reflection. So what this means is that if the point xy lines on f, then the point yx is going to lie on f inverse. To illustrate this point, think of it this way. If 2, 3 is on f, then we know that 3, 2 is on f inverse. If a point is reflected over the line y equals x, we're simply going to switch x and y to get the new point, the new image, which would show up on the inverse graph. So notice here that the x values are the same. The x value on the first and the y value on the second are the same, and the y value on the first and the x value on the second match up. So this suggests that the domain of f is going to equal the range of f inverse, and likewise the range of f is going to match up with the domain of f inverse. So I showed you an example of a point, 2, 3 on f, how it becomes 3, 2 on f inverse. Well, imagine this happening with every point. So what we're summarizing here, what we're saying here, the domain of the first matches up with the range of the second, and vice versa. Okay? So sometimes you are going to be asked to find the actual equation of an inverse function. To do this, you are going to switch x and y and solve for y. Once you have solved for y, you're going to replace it with f inverse notation. One final note. If you were to do the composition, f inverse of f of x, it would give you x every single time. And likewise, if you were to put an inverse into the original function, that would also give you x. So why do we bother with this? Well, this is a great way to check to see if your inverse equation is correct. So let's take a look at an example here. Suppose we're given this function, f of x, or y, equals 3x plus 6. We want to sketch this and the inverse below without actually finding the equation for f inverse. So if we were to graph the line 3x plus 6, we know that we're going to have a y-intercept here of 0, 6. The slope is 3, so it's going to be fairly steep. Okay, so this line right here is my equation for f of x. I'm going to draw in my y equals x line, because we know a function and its inverse are reflections over that line. So if we know 0, 6 is on f, we know that 6, 0 is going to be on f inverse. So again, it's a reflection over that line, it's a mirror image. So if we were to draw this based off of that point that we know it's passing through, okay, notice that they're going to intersect right there. This would be our f inverse graph. Okay. Of course, it might be easier to find an additional point that we know is on f to help us with our graph, but I'm sure you get the idea. So, if 0, 6 is on f, 6, 0 is on f inverse. Okay. Now suppose we want to find the equation for the inverse. So we start by writing out our equation. I'm going to replace f of x with y, so we have y equals 3x plus 6. First step is to switch x and y, and then simply solve for y. So I can subtract over my 6, and then lastly to solve for y, x minus 6 divided by 3 is what I get. Now if I were to divide each of these by 3, 1/3 x minus 2 is another way that I could express this inverse. So this is my inverse equation, which I actually graphed up above. Okay, it should make sense to you that the y-intercept is -2 and the slope is 1/3. It's not super steep. Okay, so that is the graph that we have up above. Alright, let's take a look at another question here. Now this time, this time we are not given a function. Instead we're given a couple facts. We're told that g of 3 is equal to 4. And we're asked to find g inverse of 4. So if g of 3 is equal to 4, that tells us that 3, 4 is on g of x. We are trying to find g inverse of 4. Well, recall what we said earlier. If 3, 4 is on g of x, then 4, 3 is going to be on g inverse of x. So if 4, 3 is on g inverse of x, this suggests that g inverse of 4, that's the x value, is going to equal 3. So that's our answer. Let's take a look at another one here. Last one. We want to evaluate, which means find the value of h inverse of 10 if h of x is equal to 30 over x minus 1. Let's approach this a couple different ways. So let's take a look at one method, which would be to find h inverse of x. So we're going to treat this as y equals 30 over x plus 1. Let's switch x and y. And now we're going to try to solve for y. So if I put this over 1, I'm going to cross multiply. We're going to have 30 equals x times the quantity y plus 1. From there, 30 is equal to x times y plus x. Remember, our goal is to solve for y. So I'm going to subtract over that x. So 30 minus x would equal x times y. And then y would equal 30 minus x all over x. Last step we said is to replace y with our inverse notation. So here we're using h instead of f. So h inverse of x would equal 30 minus x all over x. So from there, if I want to find h inverse of 10, I could simply plug 10 in where I see an x and get my answer that way. So 20 over 10, the answer would be 2. Let me show you an easier way, because sometimes you're not going to actually be able to find your inverse equation. Sometimes it's going to be too complicated. So if h inverse of 10 is what we are after, notice that this 10 is an x value on h inverse. If it's an x value on h inverse, it's going to be a y value on h. So I'm going to go back to my h of x is equal to 30 over x plus 1 equation. So one more time, if this 10 is an x value on h inverse, we know that it will be a y value on h. So that means I could put 10 in for y, which is really h of x, and then keep this side the same. So if I put 10 in for y, I could now solve. If I put this 10 over 1 and cross multiply, I'm going to have 30 equals 10x plus 10 when I distribute my 10. Subtract over the 10, we get 20 is equal to 10x, and x is 2. So notice that we get the same answer of 2. Alright, so my final answer of 2 can be found by first getting your actual inverse equation, or second, if you want to bypass that, which again, sometimes you're going to have to if it's too complicated to solve for y. It's not always going to be possible. So you have to understand this second technique, which is to plug in this x value of interest into that spot, h of x. So an x value on h inverse is the same as a y value on h. Okay?